Two numbers are said to be inversely proportional when an increase in one leads to the proportional decrease in the other. So if I had two numbers, and for whatever reason, when I doubled one of them, so let's start with 2 and 4, for whatever reason, if I doubled one of them, I would have to cut the other one in half. If I doubled the first one again, I would have to cut the other one in half again. These columns and numbers, let's call this x and y. In this case, x and y would be considered inversely proportional. So we see inverse proportionality in an instance of something like this. We have the time required for a certain length is the time required for a trip of a certain length is inversely proportional to the speed you travel. If you're double your speed, you're going to cut the amount of time the trip takes in half. Yeah, not generally safe to go double the speed, but I suppose it depends on how fast you're starting with. Alright, so if a certain trip takes 2 hours at 50 miles per hour, how long will it take at 60 miles per hour? So we'll go ahead and say, I guess I should probably finish the rest of this stuff up here. When we're drawing inverse proportionalities, we do this same alpha symbol we saw with direct proportionalities, except now we say A is proportional to 1 over B. And so what you can do is you can say A times B remains constant. So A times B equals K. So in this case, if we said that since the time that it takes to drive is inversely proportional to the speed, we could say the time it takes times the speed must remain constant. And in this case, we know that the time it takes is unknown here, and the speed you're going, it should be 50, is 60 miles per hour. You can see we get 2 hours times 50 miles per hour equals x times 60 miles per hour. Now, this seems a little contrived, and it frankly is a bit contrived, because we actually have a specific number for when we multiply the speed times the distance, or yeah, the speed times the time like this. This is just a measure of the distance. Of course, the distance must remain constant. This is going to be 100 miles. But this, the whole idea of setting these up is still the same. Alright, so we got 100 miles is equal to x times 60, and solving this we get, dividing both sides by 60, 100 divided by 60 gives us 1.6 repeating hours. I know that this is in hours because I'm talking about how long it will take, and you can see it was originally measured in hours. Also, I mean, we're taking what is this, miles divided by miles per hour. You can kind of see the miles end up canceling out, and we get, well, you can use some rules for fractions to figure out what happens to that hours. Alright, so let's do another example here that might not be quite as intuitive for you. In an automobile cylinder, the pressure is inversely proportional to the volume if the temperature does not change. Okay, well, again, this may not be the most realistic example, because usually if you're in an automotive cylinder, if you change the volume, the temperature is going to change. If you change the volume, if you compress a gas, it's going to heat up. That's just a natural consequence of compressing. But in any case, this is a contrived example of what is this, Boyle's law? I don't remember what it's called. Something from chemistry. In any case, what we say is that we're going to have constant temperature. That's why I say that this is contrived, because generally the temperature would not remain constant as you compress. But, so I guess pretend for a moment that we compress the gas and then we let it cool back down to room temperature. Alright, so the pressure is inversely proportional to the volume. Pressure is inversely proportional to the volume. So P is inversely proportional to V here. P is proportional, directly proportional to 1 over V is another way of saying that. Our P times V remains constant. So if we take the pressure times the volume, this is going to remain the same for any situation here. And that's the way I'm going to approach it. I'm going to say the pressure times the volume remains constant. So if the volume of a gas in the cylinder is 300 cubic centimeters, let me just write that as cc. When the pressure is 20 psi, what is the volume So X times when the pressure is increased to 80 psi. So you can see I have volume, or I guess I switched that around, didn't I? I have pressure over here times volume equals pressure times volume. So those remain constant. That's how I set this equation up. And to solve this, I would just divide both sides by 80. I'd get X, the thing I'm trying to solve for right here, is 300 times 20 divided by 80. Plug that into my calculator. 300 times 20 divided by 80. That's 75. And this should be in cubic centimeters. Let me think about what this means. This says if we have increased pressure, if I've quadrupled the pressure, you can see I went from 20 psi to 80 psi without changing my pressure, my temperature rather. I went from 20 psi to 80 psi. That means my volume would be cut down by a factor of 4. You can see this 300 divided by 4. That's exactly the number we came up with. So I quadrupled, I multiplied the pressure times 4, it would decrease the volume by 4. That's exactly what this is saying. But we didn't have to have that sort of intuitive approach. We were able to just plug it into the equation.